coders. In the channel we solve LeetCode questions, and also from today we're gonna solve GFG questions too. Let me introduce some my channel vision or something like that. Uh, we solve questions here so that we can explain the questions to interviewer fluently, like how we talk fluently. Likewise, we want to explain the questions fluently and want to make interview happen and get selected for that company. And we might think ki, like I think ki throughout the my mistake, you and me both will learn how we can improve our problem solving and problem solving explanation skills. And also you need to watch my uh, whatever mistake I do, that will be common for you also, cause I'm just starting these things. And the thing is ki I'm also kind of bad at explanation, but I'm improving, and that will be the same scenario for you. But you might be like, so sometimes that happen ki we are good in finding mistakes of others, and we might fail to find mistake ours, and that happens. Like I also do. Like someone explains problem to me, I say him or her that you should have told this to me. You should have explained this to me, and you failed to explain this, and or you didn't told me this, and I'm judging on basis of that. And I don't want if, that interview should judge us on such things. So from today, we also solve the POTD. I mean, not every POTD. I'll try to upload the POTD of POTD questions like POTD lit code or POTD GFG. Today we'll see the POTD of GFG. It is like I was solving it, and it's crazy. Like I just wrote what I imagined, and it gets solved. And I also want to share that with you, that how I approached it, and what was my what was the way in which I was thinking. So let's go to the screen. Let me take you to the screen. Give me a minute. I mean a second. Yeah. So yeah, sorry. Happens. So let's see what the question is. The question is, this is the today's question, and today the date is 16 October, 16 October 2025, and this is our first GFG video, GFG POTD video. So let's see the what the question is first. The remove BST keys outside given range. Okay. First I wrote the remove. My mind automatically go like started thinking about the deleting keys in BST. Okay, and then let's read the question. Given the root of a binary search tree BST and two integers L and R. Okay. Remove all the nodes whose values lie outside the range L and R. So I was imagining the L and R. I want only the numbers in that number line, and if the number is less than L, I have to delete it, and if the number is greater than R, I have to delete it. But by thinking that what I used to delete, like everyone maybe have their own deleting method, but what I do, if I'm deleting a node in the BST, then I replace it with a right point, like whatever the node is at right, and whatever the node at the right, leftest left, or we can say the most left to the roots right and then left. I replace the node with that number, like that node, and I delete ultimate the last node only. But here what they have told us ki modify the tree, modified tree should also be the BST, and sequence of the remaining node should not be changed. Well, while deleting the traditional thing, like tra- deleting traditionally, that go to the right and go to the left of that right, like left of wherever the left where it will take us, like left at left until we get the null, like not the null, we don't want to get null, but node before that null, we will replace the node that we want to delete with that node, and we will delete the ultimately that node only. Yeah, that was the concept, but they have told us ki sequence of the remaining nodes shouldn't be changed. So in that case it was changing, and yeah, I need to think here, like that approach wasn't applicable here. So what I thought ki yeah, it is like after reading this we get ki it is a recursive problem that we can do that. And after like okay, and whatever I told you कि we want to delete the node which whose value is less than L and or whose value is greater than R. So first I wrote down, like here I wrote down, but I will type here that you should know ki what first I thought and what was the approach. The first I thought about the best condition. What was the best condition is root is equals to null. If root is equals to null, return null, right? Let me write that in code itself. If root is equals to null, then what we will do? Return null. That we don't need to check about the L and R. Like there is no value, so return null. What if root is not null? And then it will have value. So what could be the value? Like now also I'm thinking the best case. What will be the best case for that value? That value is that value should be in between L and R. So else if root value is basically data. In lit code we use val, but in GFG it's root data. Like they have told us, and I'm not just saying ki it's always like that. Here they have given the node structure in which they have mentioned that in data will be there as nodes value, and we'll keep it we will use it as root data. Here I'm using arrow because we are using pointers here. Just read about that first, like if you don't know why we use arrow. Okay, that's not the part of the question. The part of the question that is what the best scenario. Like first best scenario was the root is equals to null, then return null. Second best scenario is if root data is less than or equal to L and roots data is greater than equal to L, greater than or equal to R. Then we don't want to remove anything, so but we want to go like we want to check if roots at the roots left, like the values at the roots left, like the nodes which are at the roots left, root nodes left are less than L, or the between the L and R, or the greater than L. Okay, it won't be greater than L cause it won't be greater than root value cause BST's fundamental rule is ki left value will always be the less than the root value, and right value always will be greater than the node's value. So we'll go to the left and we'll check if all root values are between the L and R, and if it is less then we will remove it. So go to the left, like roots left, and here what we want to do, here we want to perform the same things, that we want to remove those nodes whose value is not between L and R. So we'll go to the roots left and we'll perform the same function. And let me write it. Yeah. And also for the right part, go to the roots right and perform the same thing. Go to the roots right and perform the same thing. Yes. Now we'll think the best case. Those were the best case. Now think about this is the number line. This is left. This is right. I don't know in camera like it's opposite or not. But just imagine left and right. The numbers which are left, I mean the nodes value which are less than L, we want to remove that. And what if ki now root data is less than L? Because we took the best scenario ki roots data is greater than equal to, I mean sorry, should we have taken roots data is greater than equal to L and roots data is less than equal to R. Sometimes I do much more big mistake unknowingly, but I always find it. That's the best thing, and we should also learn that. Like while telling the interview, and we tell the like we usually tell what we are approaching, but while writing, some mistake happens like this, like what I did now. That was one of the mistake. Like also I have did this some same mistakes in previous interview. I'm improving it, and you also improve it, and just remember ki we don't have to repeat it. Okay, so okay, that was much more again. We will see the next what we want. Ki we took the best scenario, root data greater than equal to L, root data less than equal to R. What if ki root data is less than equal to R? I mean sorry, less than or equal to L. What happened? Less than L. Sorry, root data is less than L. Then what we will do? And the next scenario we will see ki if root data is greater than L, then what we will do? Root data is greater than, if greater than L and less than equal to R, then this will happen. And if root data is greater than R, then what we can do, that we'll see. So here when root data is less than L, then what we want, just imagine root data, and what the BST rule is, whichever the nodes at roots left will be the less than the roots value. So if the root value itself less than L, then the root's left value will also be the less than L. I mean, obviously it's the rule only ki if you are going to the left, its value in that nodes will be less than the root values. So we want to okay, cut. We want to cut that part. So to cut that, we just will do ki if roots value is itself a less than L, then we don't want its left part, so its root left will be null. We cut it. We just cut it out, and what we want to go roots right, and we want to find which nodes we want to remove. But wait, what we want here, like what first I did ki we want to go left, and roots left will be null cause we don't want the nodes with less value than L. And we will go to the right and we'll perform the same thing that first I thought. But what about the root value? That we want to remove the root value. So do we need to write any function here between it? No. What we'll do ki root itself we gonna replace like whatever we will find it here in removing at the roots right. That will be our root. I hope you understood it. Ki we first I think this is clear. If root itself less than L, then its left part will also less than that L. So we will cut it, and its roots right will get the value which will use to replace it to the roots value. And so for that we'll do the root is equals to remove keys and return the node whichever the suitable for that node. I mean it's that only key. Go to the roots right and take the node which can fit for that root. So here instead of roots right, we'll write the root is equal to remove keys to the roots left, like roots right, sorry. And what if the roots data is greater than R? If roots data is greater than R, then its right will be greater than R, cause its rule ki its left will always less than the node's value, and its right value will be greater than its root value. So root value, the nodes which are at right of the nodes which are at right of the root, they will always their value will always greater than the root's value, and cause root's value itself greater than R. But we can find the lesser value which can be lie between L and R at the left point. So we will search a node or root at the left, we can use to remove that node, and we can basically swapping that. We're not the swapping, but we are removing that node and we are placing the another node. But here that node will be, that node's value will be between left and right. So we'll go to the roots left and we'll find a value whichever between the left, sorry, we'll go to the roots left and we'll check this key roots left and check it. But we also want to remove the roots value, right? So to remove that, what we'll do, instead of just doing this, like go to the roots left and remove keys to the left, remove keys to the while going to the roots left, we want to remove it, but itself we want to replace that root nodes value to the root. So root is equals to remove keys to the root left, and also roots right will be null because roots value itself greater than r, then root right value will also greater than r. So root right is equals to null, and after all the operation will return root itself. So let's go and see what happens. Like it should work. What happened? Root right. What I wrote right. Where I wrote this right. Root left, root right on 28. Oh, sorry. Roots right is equal to remove keys from roots right and LR. What happened? Okay, I thought it's endless something happened, but not. I think no. It should pass all the cases. No, it's not. What could be the problem? That root data is greater than equal to here, root data is less than equal to r, then go left and do this, right and do this, and for root data is less than L, then root left should be the less is equal to null, and root should be roots, go to the roots right and LR. If root is equals to root data is greater than R, then root is equals root, let me do this, that root right is equals to null and go to roots left, but this shouldn't cause any problem. This should go to the roots right and is equals roots right should be null cause we don't want any greater value, and root is equals to remove keys, go to the left and remove those keys. Yes, it should work. Let me custom input and 1 and 3. This shouldn't happen. Like where could problem is arising? Like it's saying give segmentation fault. It means we are it passing. So let's submit it. It passed. But what happened? Like here, what we have done, key roots right. We didn't did the roots right is equal to null, and we went like before making it null, we went to roots left and we did. And after coming, oh, got it. We are changing the roots value, and again we are changing the roots right value. You getting it? Like the nodes whose value we want to remove, that it that's right should also, that's right should get changed first. Then we'll remove that node with in that anything that we want. That I think you get it. Key what I wanted to try and what because of that only our code get failed. And yeah, I understood, and I think you also understood ki what was the problem here. Yeah, and that's all for the today's. And yeah, I hope you guys enjoyed. Thank you.